Assalamualaikum warahmatullahi taala wabarakatuh. Right. Okay. Thank you, Ain. Thanks for those coming for a sharing session today, inshallah. Right. Can you see my slide? All right. Thank you, Ain. Right. Thank you, Dr. Nizam. Right. So, inshallah, today I would like to share on the topics on identifying problems root cause effectively using TRIZ method, inshallah. Right. So we don't have much time. We just have 1 hour, inshallah. Right. So I try to share what I have with all of you, inshallah. All right. So this sharing contents will be some introduction on trees, right? So what is trees actually, and what is inventive problems, and also how the trees works, the advantages of trees, the ideal solutions, and also the application of trees in inventive problem solving, right? So basically, I try to focus on the root cause problem identification, cause and effect analysis, and also trimming, right? So basically trees have a lot of tools that we can use for solving problems, but with this 1 hour I believe that we couldn't use all, right? So but I try to focus on those particular tools and solutions, right, inshallah. Okay, as learning outcomes, at the end of the webinar, after this 1 hour, inshallah, all the participants will be able to understand the basic trees concept, and also will be able to apply cause and effect chain analysis and also the trimming method. It's quite simple, inshallah, right? So maybe for those that coming today, you can apply this in your daily life, in your during your workings time, right? As to solve the problems happens occurred during your workings or daily life, inshallah. Right. Okay. So things that what you have to know basically is what is trees, right? So this might be a new word for you, right? So trees basically is come from the Russian word they call as a Theoria Rationia Isobritatelskих Zadak, right? It's quite difficult to pronounce it, okay, but normally we call it in English, right? Basically trees is a theory of inventive problem solving, right? So problem solving, analysis, and forecasting tool, basically the definitions of trees, right? So who invent this? The inventors of trees basically is the Russians. Um, uh, we call as the Genrich Altshuler, right? We call Altshuler, right? So uh, he is the one that invent this trees method, right? So how basically Altshuler invent this, right? So basically Altshuler he was prison during his time, right? So on that particular time, they study thousands of invention patterns, right? So from that particular patterns, right? So they create the methods, and that method basically is what they call as the trees method. All right. This is the guy, the Jenry Satsula. Orang kata this is the guru of the trees lah, basically, because he is the inventor of this method. And currently, this method has been used by many big companies like Samsung, Ford, right, and many others, right? Many others. Okay, so as we know, the trees is about the inventive problem. So you might be asked, what is the inventive problems, right? So basically, if you realize, in our daily life, right, we have a problems during working, during our daily life problems, right? So and sometimes the problems comes with the contradictions. Okay, so it means that if you have a problem, you want to solve, and you want to solve that problem. um, the problems could be solved, but the another problem is coming in. So that is what they call the contradiction. Okay, so the inventive problem basically is about the problems with contradictions. So whereby the solution taken in solving a problem will create another problem. Okay, so normally that happen, right? So normally that happen. Yeah, you try to solve one problem. Basically, you solve a part of it, so another problem is coming in. Okay, so that is the inventive problem. So like examples, strong but heavy. Okay, you want the strong table, but it's really heavy, right? So you solve, basically you solve a table. I mean you solve a material, solve a table. You get a strong table, but it's very difficult to leave it. Okay, effective but complex, fast but use high energy, right? So this common thing that happen, like example, we have a car, we have a Ferrari, so it's really fast, but of course they eat a lot of much of your fuel consumption, right? So that basically is problem with contradiction. Large but require big space. Okay, that is examples of the problems with contradiction. So normally the solutions that we have, right? The solutions that we have is the trade-off. You get one, you lose one. Okay, so that's what we normally did. But in trees, right? In trees, um, the solutions will giving you up to solve even the next problem. Okay, so but the only things that in today for this 1 hour, right? So uh, I couldn't go beyond that particular solution because they would take a lot of time. But just want to tell you that the trees are capable to to solve the kinds of inventory problem. Right. So basically, the tree's goal, as I mentioned to you, to take off the to eliminate the trade-off and give a strike ideal solution. Okay, that basically is tree's goal. So once you know what is trees, and once you know what is the inventive problem, so of course you will ask how the trees work actually. Okay, so this is general flows of how trees work. So basically, uh, when we have the when you have the a specific problem, right? So we will use trees to generalize the problem, right? So once we use the methods of trees to generalize the problem, right? So basically, we will use the tools in trees to get the general solutions. And finally, from the three general solutions, then you can come up with your specific solution. So basically, what that you have to know in trees, it will not give you specific solutions, but from the general solutions that derive from the trees tools, basically will help you to solve the specific solutions that you have actually, right? So um, even though some people say that if you have if you're not really creative and in thinking, right? So you couldn't give a really good solutions, but by using this tool, it will help you and it will assist you to give and creative solutions for your problems, right? So that I believe is one of the good things of how trees work basically. Right. So advantages of trees. Right. So yes, of course, it could break the psychological inertia to be creative and innovative. Right? Some people say, as I mentioned earlier, like some people say, if you want to solve the problems, design problems, you should be creative and innovative, right? So uh, if that happen, I think not everybody can solve the can give a good solution, because not everybody is creative and innovative, right? So but trees give you an advantage to be a creative and innovative by using their methods, right? So and also um, it will improve the individual and team's ability to solve inventive problems. Right, basically, when you're working in your company, in your factory, right, if you have a problem, so normally, as I mentioned to you, you have the physical contradictions, right? So you have one problems and you solve one and you create another, right? So by using trees, right, basically you can solve that physical contradictions. And even though when using trees, basically you can predict the trends of product or system evolutions, right? So this is parts of tools that we have in trees, and this basically will assist you on the product development in your company, right? So as like examples, like if Samsung's now is coming up with Samsung's S20 as example, right? So for the next product, they are thinking of S21, S22, right? So that kind of soft tools also will available in trees in order to predict and the trends of the product or the system evolutions. So not only that, so the trees also are helping us on solving problem based on the product or process functions. All right. So for some cases, we have the old product, right? We need uh, to modify to the product in order to reduce the cost, right? So we can use the solutions or tools in trees in order to reduce the function, reduce the cost, but remaining the same functions as is before, right? So by using trees method, basically could help that. Okay, so the most important for the company out there is about the maintaining the functions, right? But the products change with a cost more lesser than before, right? So that what most important, and that need a really a creative innovation thinkings on the ideas of the products, right? So um, by using trees method, inshallah, then we can get that kinds of ideas. Right. So, and please also help you doing things correctly, right? So, as you can see, this figure, right tool for the right job, right? So, if you use the wrong tools, basically, it wouldn't fit for that particular job, right? So, and it will give you have another harms to you, right? So, uh, hopefully that trees will help you assist on using as a right tool for your problems. Right. Okay. Let's see what is an ideal solutions. In trees, there is terminologies of ideal solutions. Right. So basically in trees, we have the terminologies of trees ideality, right? Or they call as ideal final result, which by the trees ideality is about the useful functions of the product over the cost and the harmful functions of the product, right? So basically the concepts of trees ideality, right? So goes by this example: the best taxi with no taxi, right? So what do you think about this, right? The best taxi with no taxi. So basically this has happened now. We have Grab, right? So this is the ideality concept, the best taxi with no taxi. we didn't own the taxi, right? Like what we have, what we have before, right? So a certain company owned the taxi, but it's not happened now, right? The owner of the taxi is the owner of the car, right? So this is the concept of ideality that brings by the trees, right? The best taxi with no taxi, right? Another one, the best hotel with no hotel, right? This also is another concept of trees ideality, right? So what is that? So we know Airbnb. Airbnb didn't own the whole hotel or the whole houses or the whole apartments, right? So they didn't own that. They own the systems, right? So what they bring, they give us basically is the identity concept. Okay. And I don't know. This is I want to ask you the best printer with no printer. Is we have possible to do that this, right? So maybe you can be owner of the systems, right? So I don't know if we can think about the Grabs or Airbnb, right? Maybe we can um, bring another company, so-called uh, printer services, printer e-line, I don't know, right? So, but it's not owned by you; it's owned by people, right? Other people. So this is concept of tricidality, right? Okay, so thinking about trees, right? So now we're looking on the application of trees in inventing problem solving. Okay, this is overall trees inventive problem solving model, right? So what I want to show to you today, basically on I will focus on the cause and effect chain analysis and also trimming, right? So my colleague on next month, we will give another topic focusing on engineering contradictions, right? So if you're thinking, we have a lot in trees, we have a lot of tools like trimmings, engineering contradictions, physical contradictions, functions model, substance models, and also REs, the algorithms of inventive problem solving, right? So basically in trees, the flows of using trees method by starting with the original problem to resolve, right? So once we know what is the problem, right? So we will go for the functional analysis, right? So I will not share with you this functional analysis today because it will take a lot. It will take a lot of times on deliver this, right? So then from the functional analysis, right, we can do cause and effect analysis and also trimming. So I will focus on these two today, inshallah. Okay. So once we do trimming, if we still couldn't solve the problems, right? So then we will go for the engineering contradictions. All right. So but I'm not sharing the engineering contradictions today. It it will took more than hours, right, for these particular topics, right? So just I want to share with you, if the engineering contradictions could not solve, then we can use a physical contradictions and continue with the function model, substance model, and also R is a final. All right. So as you can see, the function analysis and the cause and effect chain analysis is a stage one in the three inventive problem solving methods, right? So that this is quite important, where the from this particular stage we can define the problem root cause, right? Hello, can you hear me? Boleh dengar tak?
Yes, we can hear you.
Okay, thank you. Okay. Ya, biasalah cakap-cakap je ni kan, takut-takut termiss out kan. Alright. Okay, thanks. Okay, so the stage one basically is to define the problem root cause. So that's why today I want to share with you on the stage one, but partly we focus on the cause and effect chain analysis, right? So how to define the problem root cause. And the stage two of three inventing problem solving, basically covering the solution, how to generate the solutions, right? So all of these from trimming until the REs, right? So is the tools to generate the solution. Okay. By the way, today I will only share with you the tools of streaming. Okay, because we don't have the sufficient time today to discuss others. All right. So start with the TRIZ tool, the cause and effect chain analysis. Right. So this is stage one tools for defining the problem root cause. So in order to know this in details, right? So uh, you supposed to know what is the cause and effect chain analysis first, and then I will share with you on the types of cause and effect chain analysis, and also how to use cause and effect chain analysis, right? So basically, what is cause and effect chain analysis? Maybe you have heard before on the if you're working with the Japanese company, right? So you maybe heard about the Ishikawa diagram. Okay, so Ishikawa is a partly of the cause and effect chain analysis, right? So Ishikawa diagram, and that Ishikawa diagram is really famous in the Japanese company, while they try to defining the root cause of the problem. They are using Ishikawa diagram, right? So it is about the fishbone diagram. Okay, so that also is one way of to to know to define the root cause problems, right? Okay, so basically a cause and effect chain analysis generate hypotheses about possible cause, reasons, and effects of the problems, right? So that's it. That basically is called cause and effect chain analysis, right? So the cause and effect chain (CEC), right, is a structured way basically. I will show the example after this, right? So on how to apply the CEC. Actually, CEC is in such a way of expressing your thoughts, your hypothesis about the problems, about some things that happens, some things that happens, and that is your hypothesis on that particular problem. Right? So basically, by using the cause and effect chain analysis, basically is help to focus attentions on the process where a problem is occurring and to allow for constructive use to facts to narrow down all the actual causes. So this is a mainly is a main objective for the cause and effect chain analysis, right? So this basically, but by using the CEC analysis, basically you are focusing on that problem and narrowing down to the and focus down to the root cause of the problem, right? So instead of diversify the problems and you couldn't solve the problem, right? So basically CEC helping that the structure of the CEC will helping you guys to narrowing down up to the actual causes. Right. So one thing that you have to know, the cause and effect chains analysis, right? So will not giving you the real root cause, right? So it's more the possibilities because the real root cause uh only happen once you try one by one, right? So and even the cause and effect chain analysis in if you apply in the factories, if you have the problems, right? So say example, you have the machine failure, right, for the line number one as example. Okay, so if you want to do and defining the problems, right? So you can use these kinds of analysis, the CEC analysis, right? So helping you to focusing down to or narrow down to the real causes. Okay, so rather than you just try and error without using these kinds of analysis, right? So you might diversify the problems and finally eventually you couldn't solve the problem, all right? So but by using this CAC analysis will help you on narrowing down to the actual causes, even though this CAC analysis will not telling you the real root cause, but it's helping you to get the real root cause, right? So we already know about the CEC, right? The cost and effect analysis. But you might be wonder how to use the cost and effect analysis, right? So I will give you the simple step on using cost and effect analysis, right? I will give you step and process, and then after that, I will give you the examples, and from there, the simple examples that everybody can understand the step and process, right? So the step number one, basically, so the process is agree on the problems and write in the effect board. Okay, so if you have a problem, right? So examples in your factories, right? So in your industry, in your company, right? So the first step, you need, of course, I give examples like you are working in a line, right? Production line, okay, example, or you're working in a team, okay. Of course, you are the experts. I mean, you and your teams are the experts on that particular line. All right. So the first step, uh, all of the members of the team should be agree on the problem and write in the effect board. Right. What is the effect board? Later I will show to you. And step number two, all right. So all the team members, right, need to brainstorm about likely causes and then sort them into the major categories or branches them depending on the method chosen. Okay, this is important. The only expert on that particular line, like, know that, or the only experts or the only members of the teams that knows the whole process of, example, the whole process of line one, right? So of course, all members need to give an input, right? So and even the input need to be categorized, right? So and from then you can narrow it down more better, right? So step three, continue a brainstorm and generate a list of costs and fill them in the appropriate categories and branches, right? This is continuing of step two, right? So still brainstorming and start to list a cause of it, a cause of the problem, right? So, as I mentioned to you earlier, only the members of the teams or line one, as examples, can doing this, right? So, if you ask line two or line seven, right, they might not be familiar with your line, your system, right? So, it will not help you. Okay, that that is um, my suggestions. That if you want to use cost and effect chain analysis uh, 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 correctly, right? So you need to follow this one, right? Step four. Once you list down the possible causes, right? So after you brainstorming with your team members, right, you need to keep asking why why this happened, right? Such example, if you have the list number one, why this happened, why else this happened, right? Until you get the potential root cause has been identified. Okay, so step five, use team best collective judgment to choose several areas they feel are most likely causes and eliminate the unlikely causes. Right. So how to eliminate? You might be you can doing a simple test on that particular problems. Particular causes. Right. So if the testings is okay, so might be that is not causes, right? So if the testing is yes, so maybe you need to continue on that particular causes, right? And step six, use the reduced list. Of course, once you eliminate the unlikely causes, then the list of the causes will be reduced, right? So, and the reduced list will help you develop respective hypotheses to prove the group theories. I mean, to prove what basically happened, what is the main, the root cause, right? And step seven, you have to validate your hypothesis to confirm the likely root cause and proceed to implement the solution. Right. This is where you are really confirm that is the root cause and start to implement the solution. Right. So and during this step process, go back and choose other causes for testing if the initial selection is incorrect. So you have to do this, right? So sometimes the problem is quite critical. So I mean, quite hard to get the causes, right? So maybe you need to repeat some step, in order to get to narrow down to the real root cause. Okay, so how to perform the cause and effect analysis? This is example, right? So this example that you might be understand, but by looking on this example, so you might know. Oh, okay. So if I have a kind of problems, I can try to use this cause and effect chain analysis at least on the first step to know, right? So like I give you a simple example. There is no light when switch is turned on. For example, this is your problems with your light in your house, right? So what will you do? So why you might be asking why why this happen, right? So kenapa lampu tak menyala kan? So why this happen, right? So you're thinking of possible causes, right? So that is automatic, okay? But we need that to be structured. So oh, maybe power is out, all right? So maybe light bulb no longer works. This is what your list. This is what mean by list that what we have discussed in what I have shared in the previous slide on this step 1 to 7. Like, oh, maybe light bulb no longer works. Maybe switch is broken. Okay. Maybe others, right? So maybe you can list down, right? Of course, this is your house, this is your light, like your bulb. So you know better. Okay. Okay. So once you list down why, right? So the next step is tested that possibility. If that is not possibility, for example, power is out. Actually, power is not out because the light is uh, off on this particular area, but you have another light on this on others particular area. So power is not up. Power is okay. So you can eliminate that. Okay. So switch is broken, but you can see with your eyes. You tested this possibility. You know, hey, switch is not broken. Okay. So you can eliminate that. Right. So others maybe a no. Yeah. So the most possible is light bulb no longer works. Okay. So then from this you are narrowing down. Why? You still asking, but again, why? So why filament broken? Maybe filament broken. But this is your hypothesis. Socket crack. Maybe the others. Okay. The others examples are others. Right. So when you look on the socket is not cracked. So you can eliminate these possibilities, the causes. Then, of course, you can focus on the filament broken, right? So then you ask again why. So that's why they call this as a why, and why, right? So cause and effect chains. So why the filament broken? Maybe the filament wear out, the mechanical shock, right? The current spike, okay? So and others, right? So after you do a testing, right? So you know there is no mechanical shock, there is no others, right? So there is two possibility now: the filament wear out and also the current spike. So then you ask why again. So you know the filament wear out because of normal wear. Of course, we have the normal tear and wear, right? For the products that you have, the manufacturing issues maybe, right? The poor current protections in circuits, the power spike from grids, right? So and then you will try asking why and why until the team member could not answer anymore. I mean, could not reach. So that on that particular moment, like you will reach the cause that is fundamental law of physics or chemistry or technology limit based on your problems. Okay, so this is where this is where the end of change is a potential as an actual cause. That's why, as I mentioned earlier, the actual they might be a potential actual cause, but they might be not. Okay, but it will help you to narrowing down to get the real problems, the real root cause. But at least by this analysis will help you to narrowing down to up to the level that you can really focus on few least wish that you really think that is the problems come from, right? So but by doing this, basically you will save a lot of time. Trust me, you will save a lot of time. Okay, and you are focusing reals on the problems, right? Okay, so that is about the stage one, the ones of the tools on the stage one, which is on the finding problems solutions, right? So on the stage two, as I mentioned to you earlier, right? So we're talking about solution generation, but now as you know, in TRIZ, inventing problem solving, right? We have two types. We have a lot, but partly we have the in solution generation we have trimming tools, and we have the 40 inventive principles, right? But today I will focus on trimming. Okay, the another 40 inventive principle like the engineering contradictions, the physical contradictions, right? So we'll be it took a lot of time on explaining this, right? And I don't think that I don't think that we can deliver in 1 hour, right? So my colleague Dr. Adrinata will share with you maybe next month, inshallah, on this 40 inventive principle. But this is really useful. Seriously, this is really useful if you are if you are already familiar with these 40 inventive principles, right? So it will give you a lot of advantages of do a solutions on the uh, um, on the on the problems that you have in your company, right? Inshallah, right? So now let's look on the trimming, on the solution generations on the trimming. Okay, this is one of the tools, right? In the trimming. For your information, um, if you have the problems, right, to solve, uh, I would suggest increase try to use streaming tools first before you jump to the engineering contradictions, like using 40 inventive tools, right? So start with the streaming, because um, using a simple tool first, right? Sometimes will help you to solve a problem rather than use uh, the more complex tools in trees, right? So using trimming first, right? So if you couldn't solve using trimming, so basically you can jump for the next tool, right? So but in trimming, right? So of course I will share to you what is trimming, right? So understand the trimming rules in trees, and also how to use trimming. I will share this one. Okay, so when talking about trimming, so you might be thinking of the trimming word, the trim, right? So trim, so editing, adjusting, so that's part of trimming as well. So let's look, what is trimming basically? Trimming in trees basically is a method of eliminating components from an engineering system to reduce or eliminate the disadvantages of those trim components. So this is a really definitions of the trimming. And trimming is used to increase the efficiency and reduce the cost of engineering system. So basically, as I mentioned to you earlier, right? So some company, I mean such example. I give you an example. If you're working in a company, right? So you are developing a product. Okay. Uh, your company need to reduce the cost of that product. So but on the same time to maintain the what they call it, to maintain the functions of the product. So what you can use is a trimming. A trimming is powerful on that. So seriously powerful, right? So but by using trimming, sometimes you can reduce the cost, remaining the functions of the product and make the product more elegant, right? So that sometimes come from the trimming tool, right? So trimming, of course, or we call removing the undesired functions. So simplest way to solve problem. Okay, so this is first tool. Maybe you can apply it straight away after this. in your company, right? So if you have problems, so these two also can help you, right? So understanding the trimming rules. So basically in TRIZ we have three trimming rules. What's that? So the first one we call rule A. What's mean by rule A? Rule A means that trim the subject when the function is no longer required, right? Trim the subject when the function is no longer required. Okay, as you can see, this image, right? So from this player, you have the what they call the audios. You can play the CD with, then you can get the music, right? So then these two combined basically are becoming this. And even now we didn't have using CD anymore, right? So this is example, right? So trim the subject when the function is not longer required. So this function is not longer required now, right? And even this not longer required now. And even this, right? The CD player is not longer required now, right? So you can see how fast the technology change, right? So the rules say trim the subject when the function is no longer required. The rules B, trim the subject where the same function can be performed the object itself, right? So as you can see, before this we can see a trolley in the airports, right? So people put a bag on the trolley, right? So but we can trim this to become this, right? Trim the subject where the same function can be performed on itself, like the bags. You put a wheel on the bags and the handle on the back, right? We can move it, right? So we get the functions of the trolley. Okay, so that is rule B. The rule C, trim the subject when the same function can be performed by other subject or the super system, right? So super system might be air, the environments, right? So the wall, your areas, right? So that is super system. Okay, so this is rule C. So you can look this, right? So maybe you can trim the subject when the same function can be performed by other subjects. Like you have you can see this image, right? So you have a table in between the chair, right? Instead of having the leg of the table, right? So the table can use the leg of the chair, right? So that's functions of trimming. And you can see this one, right? So this is how the concept from IKEA, right? So you can use a table without a leg, but the function is same, right? So the most important the functions. So you can still put your laptop on that. You can still put your desktop on that. You can put your book on that, right? But you can save your area, your space, right? So this is a part of trim. You can get kind of this concept from IKEA as example. Okay, it didn't have a leg, right? You just use a super system. I mean, in this case, a super system is a wall, right? So the table is plugged on the wall, and you can flip it when you didn't use that, right? So you can flip it on when you want to use that. Okay, so it's really useful, right? So another example is like this. You are really using super system. Why am I saying super system? You create a table, a chair, right? But you didn't need an umbrella. You use a tree as an umbrella. Okay, so this is what we call trimming, the rule C, right? All right, so the second question is how do you trim? How do you trim it? So the first step, you have to know how do you trim it. Right? Step one, do a component analysis. What are the components of the system? Right? So you have to know if you have a one component, so you have to know the functions of the you have to know the components of the system. What is that? And you have to know you have to understand the interactions between the component, right? So say example, you have a table. You have to know the functions of the leg of the table. You have to know the functions of the table itself, right? So you have to know the main useful function. So that is step number 2. Step number 3, build a function model. Which part can be trimmed? I will show to you after this, right? So basically, to do a function model, you need to learn another few hours, right? So, but never mind. I try to give you a simple examples on a build a function model after this. So from the function model, basically you can know which part can be trimmed. Okay. Okay. And number 2, right? So which trimming rules did you apply? We have A, B, and C, right? So rule A, you don't need the functions anymore, right? You can trim that. Rule B, the object perform the function itself, like you can see before, right? And rule C, some other components does the function. So which one that you apply? So you can choose which one that really appropriate for your trimming. So, and of course, after step 1, 2, 3, right? So after rules A, B, C that you choose, either one, right? So of course, you want to look how it's look like. Okay. So that's really important. When you do trimming, so of course, I think that the physicals looking will be changed, right? It will be different. Okay. So this is step, and let's look on the examples. Okay, example number 1. What is the main useful functions of a toothbrush? Okay, this is step 1, that you have to know the main useful function. So the main useful functions of a toothbrush is to remove plaque from the teeth, right? So, and now once you know the main functions of the toothbrush, the next step is perform a functional analysis of a toothbrush. So how to do the functional analysis? So you need to get a flow of it. I mean, the connection, the interactions between the components. The toothbrush, we have the handle, of course, right? And this is toothbrush. We have a handle on this. Okay. Then what else we have? We have the bristles. This is what we call bristles. And we, of course, we have hand to hold the handle. This is what I call the function analysis. Hand, of course, your hand hold the handle. The handle hold the bristles, right? So that basically the perfect function analysis of the toothbrush. And of course, the bristles remove the food. Okay, this is a perfect function analysis of the toothbrush. Right. So once you know this function analysis, once you create this function analysis, you can perform a trimming. So which trimming rules do you apply? So you have handle, you have bristles, you have hand, right? So you have foods, right? So I can trim handle, okay? So I apply rule number C, rule C, right? So some other component does a function. What is some other component? Your hand. Your hand hold the bristles, right? So your hand hold the bristles, remove the foot. So what does it look like? This is the one. Okay, so you can use this one instead of bring the toothbrush. You can bring this everywhere, small, can put anywhere, right? So, and basically you cut the cost of the toothbrush. All right. So, and even though we use this one for to brushing the teeth of our baby, right? So this is what we call the trimming examples, right? So you just think of by just a kind of this example, basically we change the physical of it, and we reduce the cost of the toothbrush itself, right? So this example, right? Example number 2, the last example before I end up. So we only have another 10 minutes before I open for question and answer and question and answers, right? So let's see on this. What is the main useful function for of a skipping rope? You know, skipping rope, right? If you're doing if you are training, right? If you want to lose your weight, you have to do a skipping rope every time. Some experts say that you need to skip for 1,000 a day, right? I don't know. I try to make it that thousands, right? So yeah, quite tiring, but is useful as well, right? Helping you to lose weight. Okay, so but you, if you want to know how the feel of thousand time skipping, you have to try your own self, right? So, okay, so what is useful functions of skipping rope? So two exercise, okay. So perform function instead of skipping rope. Okay, we want to look on the components interaction. So first we have handle, right? We have rope, we have hand, of course, to hold the handle, right? Hand hold the handle, handle hold the rope, rope hold move the people, right? Of course, when we skip, right? So we will move people, right? So people with jumping, that what called move, right? So then we have to perform trimming. Once we have the function analysis, we need to do a trimming. So which trimming rules did we apply? So we have handle, we have rope, we have hand hold the handle, handle hold the rope. We already know this one, right? By the function analysis, we move the people. So why not? We use the rule number C. Some other component does the functions. We move the handle. We trim the handle. So what will happen? The solution number one: hand hold the rope. Rope move the people. A simple, right? So we can use this one. Okay, you just buy a simple rope, then you hold your rope without handle. It's really reduce cost, right? Okay, that is solution number one, right? So maybe you can do another solution. You move the rope. That will be solution number two. Hand hold the handle, handle move the people without rope. This is another solution. You do a trimming, right? You do a trimming, you reduce the cost, and the functions of the skipping rope become more elegant. And this is what we can see now. This is in the market. The cordless jump rope, right? You feel, I bought this one. You feel the weight of skipping, but on the same time, the rope is not there. And you will not having the problems of the rope when the rope hit your leg, right? Sometimes the things happen, right? So you just can simply skip without the rope. Okay, and the slowly patterns this is the kinds of product by using the concepts of trimming. Okay, so it looks more elegant, simple to store, right? Because you will not have any problems with tangles ropes, right? So it's really nice, and I really hope that, yeah, but by using the trimming concept today, right, so you can solve a lot of problem in your industry, in your company, right? So even though in your daily life times, right? Okay, so that's all from me. The trimming tools, right? Trimming tools that I share with you, and the cost and effect analysis, and this is 40 inventive principle that we be shared my colleague on next one, inshallah, right? So in on engineering consolidation. So stay tuned. If you this is a TRIZ training syllabus. If you want to know, you can go for the my TRIZ Malaysia TRIZ innovations, right? Or even you can email me if you want to know details, right? So you just see to get the basic TRIZ understanding 2-day class, level 1 2-day class, level 2 10-day class, level 3 and and others a week class, right? So it took time, right? Okay, but what I'm sharing with you today is a sub part of it, right? A lot of knowledge that you need to go on these trees, right? So if you are interested, you can go for this particular training, right? So you can email to me, you can email to Dr. Ridwan, you can email to Dr. Adri, right? So to get no details on that particular trainings and to know details about trees as well, right? So and you can join my TRIZ UTeM in our in FB, right? So if you have anything, you can PM, you can private message in the TRIZ UTeM as well, right? All right, that's all from me. Thank you very much.